At the end of this video, you should be able to interpret data in tables and graphs and recognize equations that summarize data, and distinguish between conventions for abbreviating units and quantities. Chapter 1, Section 3, Mathematics and Physics. Just as a physicist creates simplified models to better understand the real world, they use the tools of mathematics to analyze and summarize their observations. Then, they can use the mathematical relationships among physical quantities to help predict what will happen in new situations. Tables, graphs, and equations can make data easier to understand. There are many ways to organize data. Consider the experiment shown in Figure 3.1 on page 23 of your text or on the screen now, which tests Galileo's hypothesis that all objects fall at the same rate in the absence of air resistance. In this experiment, a table tennis ball and a golf ball are dropped in a vacuum. The results are recorded as a set of numbers corresponding to the times of the fall and the distance each ball falls. A convenient way to organize the data is to form a table, like Figure 3.2 on page 23 of your text or on the screen now. One method for analyzing the data in Figure 3.2 is to construct a graph of the distance the balls have fallen versus the elapsed time since they were released. This graph is shown in Figure 3.3 on page 24 of your text or on the screen now. Because the graph shows an obvious pattern, we can draw a smooth curve through the data points to make estimations for times for which we have no data. The shape of the graph also provides information about the relationship between time and distance.
The shape of a graph can tell you about the relationship between sets of data. This graph shows a linear relationship. As the mass increases, the volume increases. This graph is similar to the linear graph, except that it is not a straight line. It curves, becoming increasingly steep. This curve is characteristic of an equation in which one of the values is squared or raised to some power. This graph has a steep curve that approaches but does not touch the axis. This curve is characteristic of an inverse square. As one value increases, the other becomes smaller.
Physics equations describe relationships. While mathematicians use equations to describe relationships between variables, physicists use the tools of mathematics to describe measured or predicted relationships between physical quantities in a situation. For example, one or more variables may affect the outcome of an experiment. In the case of a prediction, the physical equation is a compact statement based on a model for the situation. It shows how physics equations describe relationships. While mathematicians use equations to describe relationships between variables, physicists use the tools of mathematics to describe measured or predicted relationships between physical quantities in a situation. For example, one or more variables may affect the outcome of an experiment. In the case of a prediction, the physical equation is a compact statement based on a model for the situation. It shows how two or more variables are related. Many of the equations in physics represent a simple description of the relationship between physical quantities. The units in which these physical quantities are measured are also often abbreviated with symbols consisting of a letter or two. Most physics books provide some clues to help you keep track of which letters refer to quantities and variables and which letters are used to indicate units. Typically, variables and other specified quantities are abbreviated with letters that are bold-faced or italicized. The difference between the two is described in Chapter 2 of your text, Two-Dimensional Motion and Vectors. Units are abbreviated with regular letters, sometimes called Roman letters. Some examples of variable symbols and the abbreviations for the units that measure them are shown in Figure 3.4 on page 25 of your text or on the screen now. As you continue to study physics, note the introduction of new variable quantities and recognize which units go with them. The tables provided in appendices C through E can help you keep track of these abbreviations. Variables with proportional relationships have predictable effects on each other. In many physics equations, a change in one variable will cause another variable to change as well. Sometimes two variables will be directly proportional, meaning that if one variable is changed by a particular factor, the other variable will change by the same factor. In the chapter Forces and Laws of Motion, you will examine the relationship between force, mass, and acceleration, expressed as follows. Force is equal to mass times acceleration. As this equation shows, doubling the force will double the acceleration for a given mass, because force and acceleration have a direct proportional relationship. In an inversely proportional relationship, a change in one variable will be accompanied by an inverse change of the same factor in the other variable. Using the same equation as before, consider the relationship between mass and acceleration. If the force remains constant, doubling the mass will reduce the acceleration by half. When solving physics problems, identify proportional relationships among variables will allow you to make easy predictions of how a change in one variable will affect other variables within an equation. Evaluating physics equations. Although an experiment is the ultimate way to check the validity of a physics equation, several techniques can be used to evaluate whether an equation or result can possibly be valid. We can also use the equation at the top of the screen now to describe the relationship between the variables in an experiment. This equation allows you to reproduce the graph and make predictions about the change in position for any arbitrary time during the fall. To make expressions as simple as possible, physicists often use letters to describe specific quantities in an equation. For example, the letter V is used to denote speed. Sometimes Greek letters are used to describe mathematical operations. For example, the Greek letter delta is often used to mean difference or change in, and the Greek letter sigma is used to mean sum or total. With these conventions, the word equation above can be written as follows. Y is equal to 4.9 multiplied by time squared. The abbreviation Y indicates the vertical change in the ball's position from its starting point, and T indicates the time elapsed. At this point, you should be able to interpret data in tables and graphs, and recognize equations and summarize data, and distinguish between conventions for abbreviating units and quantities.